Alright, I'm Priyash Nayak and today I'll be talking about the maybe data type in Haskell. So there's something I came across while I was researching a bunch of concepts for Haskell, and at the time I didn't really understand what people were using this when they were trying to build up their code or when they were doing some error handling, because Haskell provides a pretty neat feature called error, and the way it works is whenever your code is you're not supposed to be doing something and you try to do it in your compiler, it just yells at you like, "Hey, uh, this is an error. It's not supposed to work this way. You failed. You're a loser." So here's where maybe comes into play. So maybe is a data type which you can use. It's a monad, which is just a neat way that Haskell has, in which when you have some sort of computation that produces some side effect, you can manage that in a very controlled fashion. So what maybe does is that you just have to declare maybe as an additional data type in your existing function. So whatever you're returning, just add maybe onto it. And what it does is that anytime you're supposed to be producing something, so that you're supposed to be evaluating an expression is supposed to succeed, you can like additionally include this just data type and which and just say that, hey, my code succeeded. And anytime it's like surrounding an edge case or some sort of error that your function is not supposed to be doing, so like it's not designed to evaluate that just yet, you can declare that as nothing. So this is a pretty neat way of dealing with errors and exceptional edge cases because this is much more readable than going through a large stack and trying to figure out where the hell everything went wrong. And it's also much more safer because you're just using an external data type. It's not really affecting the original data or how your code is supposed to be working. It just adds on to it. So, and it's much more readable than something like try except. So, like, let's talk a bunch of code. So, I have this implementation of head, and I tried running some stuff. So, I did I had 1 to 3, give me one. I did I had just one, it gave me that. And when I tried to do an empty list, it gave me no access to pattern because I didn't really include one case for it. But the code compiled, right? Why did it discover no exhaustive pattern back then? Let's look at another one of my coding examples. So it's gonna be HS. So here I have unsafe head in which I declare if you're using an empty list to an error. So I'm just gonna run my code. Unsafe head, I'm gonna give it just one. Make it quick. Gives me one. But if I give it an empty list, it'll tell me that hey, there's an error. It's not supposed to work this way. Fucked up, right? Let's try my safe version real quick. Just one. If I give it an empty list, it's really nothing. So why did Haskell not catch all of this stuff, all of that neat stuff when I was already compiling everything? Why didn't it catch the non-exhaustive pattern? The way maybe works, the way this class works is that when it has all of these cases with nothings and just, the compiler reads them and declares them as such that hey, this is a sort of scenario in which the output is going to be nothing, in which that's going to evaluate to nothing. So it still succeeds because it does succeed. But what did I get? Nothing. I don't need this. I don't have anything for you for this. But anytime else where my function is working as intended, it produces just the keyword and then it gives me the output or whatever expression is evaluating, not necessarily IO. It's pretty safe because all this happens at compile time as respect to all this error checking, this non-exhaustive pattern checking, this exceptional handling that happens at the runtime in which the user presents you with a certain case that's not supposed to work as a function not supposed to cover that and it yells at you. So it's pretty neat because you don't have to look through a bunch of lines of where things went wrong because let's be honest, Haskell is very rough error handling way. And when you're using a bunch of different libraries, it gets really worse. So this is a pretty neat way of and a pretty readable way, I'd say, of doing error checking because I didn't really have to include a lot of other stuff, right? It's just one variable just here and one variable, nothing there. Not much, pretty readable. It does this at compile time, manages everything real quick, and it doesn't have to go far. Look at a bunch of other examples like doing unsafe to up, which converts a lowercase string to an uppercase string. So I'm just going to give it my name. Works. If I give it an empty list instead, it also means, hey, I'm not supposed to map a certain function to this function to upper to an empty list. If I try the same thing with my safe function, implement maybe, it's able to evaluate that. It's able to evaluate both of these cases because this happened in compile time. It succeeded. So this is a pretty type safe way. I'm not manipulating my data in any sort of fashion. I'm specifying that I have a bunch of edge cases when I'm building up my code, and they're not supposed to be, like the user is not supposed to go like do that sort of task. So it's not supposed to make the function do some sort of like really outrageous task that I don't have the functionality to handle. And it's really neat to do so in production when you're working with much larger programs, much larger libraries. So like let's look at this unsafe C2F. So like we know that if a temperature in such as goes under the absolute zero, so like let's just give it 900, it's not supposed to really work, but instead when I'm building up my code, I can declare it as maybe that, hey, this is a scenario my function is not supposed to be working with. You're not supposed to be giving me this. Another example is like the divide by zero error. So like Haskell often yells at you. It gives you, again, mathematically, like dividing by zero is supposed to give you not a number or infinity. So I can test it out. It's here. It's going to give me infinity. But since this is not really some sort of computation it's supposed to be doing, it's going to do nothing. So yeah, maybe is a pretty neat way of having your code have situations in which it says that you're not supposed to be working with it this way. So as you do your production, as you're building up a hierarchy of what sort of bugs you should be fixing, what sort of features you should be adding on your code, and what sort of like edge cases you should be exploring. It's a pretty neat way of just using this maybe data type because it doesn't really affect it in a lot of like annoying ways. It just adds on to your existing code, and then you can have a priority list of what more features your code should have in the end and document it accordingly. So yeah, I thought it's a pretty neat thing that Haskell has that doesn't really manipulate too many things and doesn't really affect a lot of your code in any sort of like wild manner. And yeah, it's pretty neat. It's honestly it's much more neater than handling exceptional cases, looking at a large call stack and looking at non-exhaustive patterns. So yeah, thank you for watching, and I hope you have a good day.